The next periodic trend we'll look at is the periodic trend in ionization energy. Ionization energy is the energy required to remove one electron from an atom or ion. So, sodium plus ionization energy yields a sodium ion plus a free electron. If you start out with a sodium ion and you zap it with IE2, this is the second ionization energy, you end up with Na2 plus a second electron. If you start with Na2 plus and you zap it with a third ionization energy, you end up with Na3 plus a third electron, and so on. Each successive ionization energy is higher than the previous one because you are removing an electron from a more positively charged particle. With IE1, you're removing an electron from something with a charge of 0. So IE1 is the lowest ionization energy. With IE2, you're removing an electron from something with a charge of +1. That's harder than removing an electron with something from a charge of 0. And so on and so forth. So, successive ionization energies increase for each element. It will always cost you more to remove a second electron than the first, and more to remove the third electron than the second. What about the trend across the periodic table? Let's look at the periodic trend in first ionization energy. The vertical axis here is energy in kilojoules per mole. The horizontal axis is group number. This is for the main group elements. Groups 1, 2, 13, 14, 15, 16, 17, and 18. Each of the colors represents a period. For instance, the green is the first period. The blue is the second period. The black is the third period. And the purple or pink is the fourth period. So, what do we see? First of all, moving left to right, the values all increase. Right, so all of these lines have a general slope upward, moving left to right. This is because of the increase in nuclear charge as you go to the right. Moving to the right on the periodic table, there are more protons in the nucleus, hence a stronger attraction between the nucleus and the valence electrons. So, since Z, the number of protons, increases as you move to the right, and that means the charge on the nucleus is increasing as well, as you go to the right, there's a greater attraction of the nucleus for the valence electron. Hence, it takes more energy needed to remove that electron as Z increases. What about the trend going up and down the periodic table? The first period, the highest on the periodic table, has the highest ionization energies, and the fourth period is the lowest of the ones shown, and it's got the lowest ionization energies of the elements shown. What gives with that? That is to say, the ionization energy increases as the period number decreases. Well, as you move down the periodic table, your valence N value goes up. Compare hydrogen with helium. Hydrogen has the electron configuration 1s1. Lithium has the electron configuration 1s1 or 1s2, 2s1. So you can see The valence value of N for hydrogen is N equals 1, and for lithium, it's N equals 2. This means that a valence electron in lithium will be further from the nucleus. And the further the nucleus is from the electron, the less attractive force there is. Hence, lithium takes less ionization energy than hydrogen. That is to say, the 1s electron in hydrogen is closer to the nucleus and therefore experiences more attraction than the 2s electron in lithium. To sum up, ionization energy increases as you go up the periodic table and as you go to the right.